In this quick tutorial, we'll talk about how we can use the package QCC to create control charts, specifically the X-bar chart, S-chart, R-chart, and the attribute charts, P and C charts. The first thing we want to do is we want to install the package. This is not a default R package, so we have to install it from an online server. So it says install.packages QCC. This is the first thing that you need to run. If you run it here, basically I already have it on my computer, so you can just ignore that. But you'll install the package. You can also come over here and press install, and you can write in the package that you want. So if you want QCC, you can write QCC, and sure enough, the little QCC will come up and you can press install. So you can also install the package that way. Once you install the package, you need to then upload or use the package in this analysis. So we need to obtain it by calling it at library, so we can run this section here. Or we can go over here into packages, and we can see that Quality Control Charts QCC is right here. We can click it here. So if it's already in your R Studio, then you can click here to make sure that it's being used by R. All right, once you get the package downloaded, then you can use one of the data sets that's in one of the packages called piston rings. So if you use data piston rings, then it will run in your data. There's 200 observations with 3 variables. And so let's look at what this data looks like. So if we look at it, it looks like, let's go ahead and scroll up a bit. Make it a little bit longer. There we go. If we scroll up, we can see that we have the diameter of the piston ring and a sample. So this would be from sample 1. There's 1, 2, 3, 4, 5 measurements for sample 1. And you can ignore this trial thing for now. Basically, we have sample 1, 2, 2, 2, 2, 2. So there's 5 observations in each one of the samples. And if we scroll down, it looks like there are 40 total samples. And then this is the quantitative measurement. So that means that we can do an X-bar, S and R chart on this type of data. All right, so now let's go ahead and just check something out. Let's see what each one of the subgroup means would be. We can do this using the familiar command aggregate. So are we doing diameter versus the sample? So for each sample, what is the average diameter from the data set piston rings? So that's what this command will do for us. And now we can see that if we scroll up, we can see for the first subgroup, the average was 74.01, second subgroup 74.00, and so on. So this is a good way that we can verify when we actually do the data, or when we do the X-bar chart, that it's going to come up with the correct values. So let's go ahead and attach this data set so we can use it in the following analysis. So the first thing that we need to do is we need to format our data set. So that's what this QCC.groups thing will do. So if we go ahead and run this section, I'll show you what the output looks like. So this is now the new diameter. So let's go ahead and run that and just see what it looks like. This is the type of format that QCC needs your data in. So notice how there's now 40 rows. Each one of those rows represents one of our subgroup samples, and there's 5 columns for each one of our measurements. So this would be all the values from this first subgroup. These are all the values from the second subgroup, and so on. So basically, that QCC.groups basically just reformatted the data so it can be used in the QCC command. Now, let's go ahead and run the next line, that's QCC of diameter. So if we do QCC, right here, QCC diameter, so the new diameter, we want the type of chart will be an X-bar chart where we use the S-bar or S-chart standard deviation. So here we get then our X-bar chart using S-bar in our control limits, where we have lower control limit, upper control limit, and then this is our X-bar bar value. We can see that overall the X-bar chart looks to be pretty good here, but then it starts to get out of control. Essentially, if we look, it looks like it's starting to just systematically increase after about 28, the subgroup of 28. So this is probably an issue and that it should be investigated. So when we look at this, we have our center, which is 74.0036, that's X bar bar. lower control limit, upper control limit. This R also gives the number of observations beyond the limit, so that's here in red, and the number of violating runs. Basically, this goes back to the Schuhart type of analysis on whether or not certain things that we see in our plot should be identified. And so this is a run, a number of violating runs, where basically you either have a ton of extreme values over the mean value. That's probably what this one is, because we have 1, 2, 3, 4, 5, 6, 7 successive values over the mean. And so that's going to be a violating run. All right, so the other things we want to look at is we want to look at the X-bar chart using R, so the ranges instead of the sample standard deviation. So if we run this line, we get the X-bar chart using R, so it looks like our lower control limit and upper control limits change a little bit. We have pretty much the same, the means stay the same, so that's not going to change. But we can definitely see that we still have some things that are out of control and that our control limits look like maybe they got a little bit smaller. If we look back, they're practically the same. So there's not much of a difference there. If we look at just the S-bar and R chart, so these are the measurements for within variability, comparing the within variability. We can see that the S chart is in control and the R chart is in control. Now you can create these using pretty much the same commands using QCC diameter, but instead of doing type X bar, where then you have to also define the standard deviation, here for the deviation charts, you just need to denote what type of chart you want to use. So here in this example, that's a type S and type R. All right, so the other types of charts that we'll talk about in this class are the attribute charts, so P chart and C chart. This is for proportions. So suppose you have count data. Basically, there's 20 observations out of 100. For like our first sample, 10 out of 100. So these are the count out of 100 for each one of your subgroups. You can run this in. What you need to do is you need to then define your data, put in the type of charts you'd like, and then the size of each sample. So that will give you then a proportion. This will give you a P chart where on the vertical axes, these are then the proportions of each then subgroups that are denoted below here. So here is then this P chart for this data. You have the center, that's your P bar. That's the average of all the proportions, the standard deviation, and the lower and upper control limits for this. In this example, there's no violating runs, so both of these are 0. Let's look at the C chart now for this data. Basically, this is count data, so we can just put in the counts as a vector, and then QCC will be the command that we'll use, again, where we put in our vector of data, and then we want to use type C, so that's our C chart. Run this, and sure enough, we get another chart. Looks like this has some extreme observations. That's definitely looks like we have a violation because we have 1, 2, 3, 4, 5, 6, 7 observations above the midpoint, and it looks like maybe this process is getting out of control because of the fact that it seems to be increasing over the number of subgroups, which are 12, and it looks like these are then the counts on the vertical axes. The center, so C bar or X bar, is going to be 21.725, and we have our standard deviation and our lower and upper control limits. So this is how we can use R to calculate control charts using the QCC command. Of course, you can also just use general plots where you calculate the lower and upper control limits and put those in as lines and just plot the points on a just general plot using the plot command. This is also okay, but it's probably not realistic in practice because you're going to have so many observations typically that it doesn't make sense to be doing anything by hand and mainly relying on your software. All right, hopefully this video helped you understand how you can use the QCC command in R to create control charts.